Okay, let's start. Hi guys, welcome to NEET World Institute and NEET World YouTube channel. Right. So I hope you guys are doing well. Like you have spent your Sunday well and you enjoyed the Sunday, right? So now let's go into the topic. That is, this series is specially for the EAPCET aspirant of 2026 for both engineering and medical stream, right? So till now we were discussing about a few chapters in physics, that is units and dimension, measurements and errors, straight lines, planes, laws of motion, then work, power, energy. So we have successfully completed these topics and the KYQs of EAPCET as well. So now we are going ahead of the topic, that is system of particles and rotational motion, right? So let's wait for 1 or 2 minutes. The people are joining over here, right? So once they have start joining now, we can start the class, okay? And note the point, like today's topic is system of particles and rotational motion, right? Okay, let's start the class, right? So the topic is, which we are going to discuss today, is system of particles and rotational motion, right? So please try to listen the topic carefully, like whatever the formulas which we are discussing, okay? Everything, please try to note it down. So once we have discussed the formulas, we'll try to do some questions, okay? So once a particular topic has been done, we will see some PYQs of the system of particles and rotational motion questions. Okay? Yes, fine. So the first topic, let's start with the rigid body. So what is the meaning of a rigid body? Meaning of rigid body: a body with a definite shape, definite and unchanging shape. Okay, so these bodies are called as a rigid body, we will say. Okay, so the distance between all pairs of particles do not change. Yes, of course. When a particle is fixed, okay, the particles, the object is fixed. No, the particles from this point and this point are there. So if I see for n number of times, the particles position doesn't change, right? So that's the meaning of that. So the no real body is truly rigid. Real bodies deform under the influence of force. So the thing, when I apply a force on a body, no, what happens there? It will try to deform. It will try to deform, like either it can extend or it will break. Okay, so those properties we will see in the mechanical properties of solids. Okay, then motion of a rigid body. Now pure translation, the first one is pure translation. We will see at any instant of time all particles of a body have the same velocity. When I talk about the particular body, okay, this is my A, B and C, particle A, B, C. If I try them, like if I take them and keep on inclined plane, having an angle theta, this body will have, like the system will have some velocity x. Then the question is asking, like what is the velocity of point A, point B and point C particles? So we have discussed about this as x velocity, x meter per second. Then point A, B, C also having the same x meter per second velocity. That's the meaning of that. At any instant of time, all particles of the body have the same velocity, right? Okay. So combination of translation and rotational motion. So when I talk about rotational plus translation, okay, so different particles have different velocities. Like for example, when I take a circular object and I have taken an inclined plane having an angle theta. Now if I see over here, wherever the contact is there, in that contact point the velocity will be 0. The velocity will be 0, right? So V1, V2, V3, V3 and V4. So this V1 is not equals to V2 is not equals to V3 is not equals to V4. So every particle will be having different velocity, different velocities. Okay. This is about a glance of what is the combination. Like if the combination is given translation plus rotation, so particles will be having different velocity, okay, at each point, okay. But in translation, only translation, the particles will be having the same velocity as the system, right? Okay. So the line or a fixed axis about which a body is rotating, it is its axis of rotation, we will say. Okay, axis of rotation. When I talk about a fan, so the axis of rotation of fan, like if I talk about this point or either this point or this point, okay, point A, B, C, every point rotating at a particular axis, like some fixed axis. That axis is called as axis of rotation, we will say. Okay, the fixed axis, the line of action, we will say. Okay. Now a potter's wheel. This is also the same, like a similar example of fan. Okay, which we have considered here in the axis of rotation, right? So motion of a rigid body, a rotational motion. Okay, rotational motion. So every particle of a body moves in a circle that lies on a plane perpendicular to axis and its center of axis. Okay. So one thing we can understand here, the particles which are rotating no, like particle 1, 2. Like axis is the z axis, whereas point 3 exactly lies in the z axis. Will that point rotates? No, it fixed in the z axis. So it's remain constant, we can say, right? That's the point here. A particle P1 describes the circle of radius R1 with its center C1 on the fixed axis. So center C1 is the fixed axis, whereas the circle lies in the plane perpendicular to the axis. Particle P3 is there, like P1 is completed, P2 also same thing. P2 having radius R2, right? So particle P3 on the axis remains stationary while the body rotates. Only the particle which are surrounded is rotating. The particle which exactly lies on the axis doesn't rotate. It will remain stationary. So okay. Now the next topic is precision. What is the meaning of precision? Precision is nothing but sometimes the axis may not be fixed. May not be fixed. So have you seen this toy? Like this is one of the example where I can say the axis will be changed. Axis will be changed when they are rotating. So the movement of axis of the top around the vertical is termed as precession. So at point of contact of the top with the ground is fixed. When I talk about the point of contact with the ground, it will be fixed. But the axis keeps on changing. Okay, the axis keeps on changing. Now, we are going into the topic that is center of mass. So, what is the meaning of center of mass? Like center of mass, like object having a mass, like center of that we are saying a center of mass, right? Okay. The thing what we can say like when the object exactly lies, like the object's point exactly lies in the center exactly, no. Sometimes like for the uneven object it can be anywhere, right? So how to find that center of mass? So for like these kind of objects, so like equilateral triangle, square, right, a circle, whatever it is, like the centers can be exactly at the midpoint, right? But for uneven shape, for example, uneven shape is there, how to find the center of mass? Okay, so here is the topic, how we can get the answer for the different objects. Okay, so it is the point where entire mass, yes, the entire mass of a system is assumed to be concentrated. For a uniform mass body, like equilateral triangle, square, okay, or else a rod, center of mass exactly at the geometrical center, right? So for non-uniform mass system, the center of mass is near to the body which is having higher mass. Suppose some uneven object they have taken, no? So the center of mass, I can say like it's around the where the mass is higher. So when I talk about some body, this side the mass is higher, this side the mass is lower. So the center of mass will be near to the mass where it is higher. Okay, so that's the thing. And the thing is, R is inversely proportional to M. The distance between center of mass and the mass is inversely proportional to M. So MR will be always constant. Mass into the distance is always constant. Okay. So it's the one of the example, Earth and the Moon. So Earth is having more mass when compared to the Moon. So center of mass will be near to the Earth's surface. Okay, near to the Earth's surface. Okay, so this is the formula. So this is the formula for the center of mass. X, center of mass. Suppose two particles has been given. That is for the rod we have considered rod. Okay, so center of mass lies exactly midway between the two particles. Okay, for the rod. But the original formula, if we see, this is the thing. X center of mass will be equals to m1 x1 plus m2 x2 by m1 plus m2. This one why we have taken no, when the mass are equal. So exactly center. We have given the thing like rod. If I take rod, okay, x1 plus x2 by 2. Suppose for example we are taking a 3 m1 m2 m3. Okay, now how to find the center of mass? So x center of mass will be equals to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3, m1 plus m2 plus m3. So this is how we will find the center of mass for x. Like in x axis. What about y axis, sir? And what about z axis? How to find that? Or is there any different formula for y axis and z axis? No, the same formula only. So y center of mass will be equals to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. What about z axis? Z center of mass will be equals to m1 z1 plus m2 z2 plus m3 z3 by m1 plus m2 plus m3. Right? So we have considered for the three masses only. Okay, if it is n number of masses, I can write it m1x1 plus m2x2 plus m3x3 plus up to mn divided by m1 plus m2 plus m3 plus up to mn. Okay, you can take this formula. We'll go for the next topic. Okay, done? Yes. So this is how we will write for the n number of masses. m1x1 plus m2x2 plus mn xn by m1 plus m2 plus up to mn. Okay, this is for n masses, n particle, x center of mass, COM. Okay, center of mass, COM. Right. So similarly for y-axis and similarly for z-axis. Then yes, so this is y-axis we have written, this x-axis, and what about z-axis? Yes, so this is the formulas we have noted, right? Okay. So center of mass in terms of position, so position vector, right? Position vectors. So here is the mass m1, m2 and m3, right? So from the origin the position is r1, r2 and r3. What is the center of mass of the given three objects? So it is m1 r1 plus m2 r2 plus up to mn rn. Like if n particles is given, so divide by m1 plus m2 plus up to mn, center of mass. Okay, so summation mi ri by summation mi. Okay, I is nothing but like n number of particles we will take, right? So similarly for y-axis, similarly for z-axis too. This is the formula in terms of position vector. So there is no difference between the formula which we have seen before and the formula which we are seeing here, right? So the position vector also having the same kind of formula only. So whenever we are talking about the motion, if motion takes place, like suppose velocity or suppose acceleration takes place, so there also the same kind of formula only are going to be applicable, right? Now center of mass for a system closely packed particles. So we'll see formula like x will be equals to 1 by m integral of x dot dm. So y will be equals to 1 by m integral of y dot dm. Why we are taking 1 by m commonly outside? Because we are considering it's a rigid body. The total mass, like when I talk about divide by m1 plus m2 plus up to mn. So n particles are there. So each particle having different masses. So if I combine the particle, the total mass of the system will be m, right? So that's why. Okay. If the center of mass is the origin, r will be equals to 0. So r dot dm will be equals to 0. Then x dot dm, y dot dm and z dot dm also will be equals to 0. Now determining the center of mass of a thin rod. So I will give a tabular column where we can see the center of mass for the different objects. Okay, no need to derive anything. I'll give a tabular column for this. Okay. So first question we will do here. First question. Find the center of mass of a 3 particle at the vertices of an equilateral triangle. Okay. The masses of each particles are 100 gram, 150 gram, 200 gram respectively. So the sides of equilateral triangle is 0.5 meter. So 0.5 meter they have given. Is this equilateral triangle is lying in a single plane? No, it's two axis. No, or single axis. No, it's two axis. So what should I do? There is 0, 0 and this is how much? It is 0.5, 0. What about this one? This point. This point I need to know, right? What is the point? Yes, this one I can say. Wait, let me write here 0, 0. This point origin. A is 0.5, 0. And this one is 0.25, 0. At this point, okay. But what about this point? This point will be having a different, right? I can't say like this is 0.5. This is 0.25. What about this point? So I can calculate, no? So let me take 0.25 the whole square plus b square will be equals to 0.5 the whole square. Why? Because sum of this two sides will be equals to this side. Square of these two sides will be equals to this side, right? So 25 divided by 100 the whole square plus b square will be equals to 5 by 10 the whole square, right? Yes. So let me take this b square this side, right? So 625 or b square will be equals to 25 by 100 minus 625 by how much? 1, 2, 3, 4 will come, no? 4 times. So cross multiply it. 250000 minus 62500 divided by 1 2 3 4 5 6 1 2 3 4 5 6. That's it. So to remove the points I have done like this. Okay, to remove the points I have done like this. Okay, so how much will come? 2500 0000 and 00, this is 625, right? 0 will go, and how much is remaining? This is 4 9 and this is 10, I think 5 7 and this is 18. 18750. So divide by 1 2 3 4 5 6 1 will get cancelled. 1 2 3 4 1 2 3 4. So 0.1875. 0.1875. Right. So this is how we will find the points, right? And we need to get the point also here. We need to get the points. And what we need to do now? The thing. Let me write. This is some x1 and this is y1. Okay, x1 y1. So x center of mass will be equals to m1 x1. Okay, m1 x1 with me this x3 y3. Okay, m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Then y center of mass will be equals to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Right. So can I give answer for this question? We'll see who is going to give answer for this question first. So who are watching in online, no, they also can give answer here. Okay, done. So what was the point you have got for the x3 and y3? Yes, it is 0.25 comma 0.25 root 3, right? Okay, so whatever we have done. Okay, same thing. Yes, it's correct. 0.25 comma 0.25 root 3. Okay, good. So it is 0.25 comma 0.25 root 3. Yes, after this we can substitute the values, right? Now next, center of mass will be equals to, what is mass 1 is given 100 gram. 100 into, what is the point x1? 0 plus how much? 150 gram. 150 gram into, it is 0.5 plus it is 200 gram into, what is the point? 0.25 divided by 100 plus 150 plus 200, right? So this one will get cancelled off, and this is 15 into 5. 15 5s are no, it's 30, 60 and 75. 75, and this two zeros will go off, that point will go off, and this is plus 50 divided by 200, 350, 450. So it is 125 divided by 450. 125 divided by 450. What about y center of mass? Y center of mass will be equals to, what is y1? So m1, let me take up. m1 is 100 gram and y1 is 0 plus 150 gram and y2 is also 0, right? Plus 200 gram into 0.25 root 3, right? Root 3 divided by, it is 100 plus 150 plus 200. Done. So this will get cancelled off, and this also will get cancelled off, and again this is how much it will come? 50 root 3 by how much it is? 450. 450, right? 450. So the points, okay, I have not calculated the exact thing, like the fraction we have not calculated. Let me write down. X center of mass comma y center of mass will be equals to 125 by 450. 125 by 450 comma 50 root 3 by 450. So this is the answer. So this is the answer. Okay, done. Can we go for the next one? Okay, let's go for the next one. So find the center of mass of a triangular lamina. What is the meaning of lamina? That's the thing we are going to see here now. Okay, so lamina may be subdivided into narrow strips, each parallel with base Mn. So if I take a base Mn, which is looking like a perpendicular, right? Looking like a perpendicular. Similarly, I am taking each strip like which is parallel to Mn. Okay, so for each strip there will be a center of mass, right? That each center of mass I will join, like the points I will join. Okay, similarly this side, like ML and Mn. If I join everything, I'll get a midpoint. That's the thing. By symmetry, each strip has its center of mass at its midpoint. If we join the midpoint of all strips, we get a median called LP. Median called LP. So similarly, there is a median called MQ and NR. So the center of mass lies on the point of concurrence of the medians. like which is nothing but a midpoint, like the meeting point of the every median. That is the centroid of the triangle. Centroid of the given triangle. So this is how the laminar works. Okay. Now let us see a problem based on this topic. Find the center of mass of uniform L-shaped lamina with dimension as shown in the given figure. The mass of the lamina is 3 kg. The mass of the lamina is 3 kg. So what I should do? The thing we can equally divide the shape into pieces, right? How many shapes they can divide? So 1 and this is 2. So this is 1 kg, 1 kg, 1 kg, right? 1 kg, 1 kg and 1 kg. So first of all, I need to find the center of mass for this point and this one and this one. If I find the center of mass, then I can get the center of mass of the uniform L-shaped lamina. Okay. So can you give an answer for this question? The way how we have solved for the previous question, the same thing. Done? Okay. So no issues. Now if I see here, I can take a line. So this is 0, this is 2. So this one will be 1 comma 0. That's it, no? So what about this midpoint? This is 1 by 2. Okay, 1 by 2. This point exactly is 1 by 2 comma 0. What about this point? This is 1 meter. So this also will be 0 comma 1 by 2. Right? No, it is 1 by 2 comma 1 by 2 will come this point. It is 1 by 2 comma 1 by 2. Then this point, it is 1 plus 1 by 2. It is 3 by 2. Right now, 1 by 2. This is total 1 and this is 1 by 2. So which is 3 by 2. So 1 by 2 comma 3 by 2. What about this point? This point is 3 by 2 comma 1 by 2. 3 by 2 comma 1 by 2. Right? Now we got the point. Let's find the thing. X center of mass will be equals to M1 is 1 kg. 1 into what is the point 1 by 2? 1 by 2. This is 1. This is 2 and this is 3. 1 by 2 comma plus again 1 into 1 by 2 plus 1 into 3 by 2 divided by 1 plus 1 plus 1. So this is 1 by 2 plus 1 by 2 plus 3 by 2 divided by 3, right? Which is nothing but how much it is? 5 by 2 divided by 3. So divided by 2. So it is 5 by 6 will come. 5 by 6. Okay, we got X center of mass. Y center of mass will be equals to 1. The point is 3 by 2. Plus 1 into the point is 1 by 2. 1 by 2 plus 1 into the point is 1 by 2. Divide by 1 plus 1. So 3 by 2 plus 1 by 2 plus 1 by 2 divided by 3. Which is nothing but again 5 by 6. So center of mass of the lamina is nothing but 5 by 6 comma 5 by 6. This is the points. Fine. Hope it's clear, right? So you can take a note of this. We'll go for the next one. Done? Okay, can we go for the next one? Fine. So the next one is motion of a center of mass. Motion of center of mass. So when we talk about the motion, right, what are the things are involved? Velocity, acceleration, force, right, etc. Like that, these kind of things are involved. Now we know that when I talk about a position, center of mass, no, so it is R is equal to summation mi Ri by summation mi. So what is the summation mi means? It is total mass, total mass. So m into R will be equals to summation mi Ri, which is nothing but m1 R1 plus m2 R2 plus m3 R3 plus up to mn Rn. So if I am differentiating with this particle with respect to time, what will we get? M into dr by dt, which is nothing but v. So m1 into dr1 by dt, like everything like this, no, drn by dt. So v1, v2, v3 up to vn, right? So again, if we differentiate with respect to time, we will get acceleration. So m into a divided by is equals to m1 a1 plus m2 a2 plus up to mn an. So the formulas which are looking like the similar formulas only. So velocity center of mass will be equals to is it visible? This, okay, let me change the color. Okay, no issues. So velocity center of mass will be equals to m1 v1 plus m2 v2 plus m3 v3 plus up to mn vn divided by m1 plus m2 plus up to mn. What about acceleration? So acceleration center of mass will be equals to m1 a1 plus m2 a2 plus m3 a3 plus up to mn an. Okay, so where a1 a2 a3 are v1 v2 v3 are called as acceleration and velocity of each particle. So m1 plus m2 plus m3 plus up to mn. Okay, this is the formula for velocity of center of mass, acceleration or center of mass, right? Yes, so that's the thing we have discussed here, like this is the formulas. Okay, now next is motion of center of mass, like in terms of force. So what is force? Force is nothing but mass into acceleration. F is equals to m into a. Now if we talk about the thing here, m1 a1 m2 a2 are this total mass, which is nothing but f a center of mass will be equals to m into m a center of mass will be equals to m1 a1 plus m2 a2 plus up to mn an, right? So m into a, which is nothing but f center of mass will be equals to f1 plus f2 plus f3 up to fn, right? So this is the formula for the force, that's the thing here, right? From the Newton's second law, we know that F is equals to mass into acceleration. For n particles, F2 is equals to m2 a2, F3 is equals to m3 a3, and Fn is equals to mn an, right? So similarly, whatever we have done in the previous slide, the same thing, right? So ma will be equals to f net. So we will substitute the formula here, f1 plus f2 plus up to fn, right? So when we talk about from the Newton's third law, internal force occurs in equal and opposite pair and their contribution is 0. So F internal will be equals to 0. So only external force is there, which is nothing but mass into acceleration, right? So the external force acting on the system is equal to the force acting on the center of mass, right? So this is the thing. Okay, so next one is linear momentum of system. So we have discussed about the things, no? Velocity center of mass will be equals to m1 v1 plus m2 v2 plus m3 v3 up to mn, sorry, up to mn vn divided by m1 plus m2 plus up to mn. What is this mn? Sir, up to mn, the total mass. Let me take here. So mass into velocity. Momentum is nothing but mass into velocity. So P will be equals to P1 plus P2 plus up to Pn. The same expression. From acceleration center of mass we got force. For velocity center of mass we got momentum. So the total momentum of a system of a particle is equal to the product of the total mass of the system and velocity of its center of mass. So the differentiating with respect to time now, what we will get? Yes. So force external will be equals to change in momentum with respect to time. So dp by dt will be equals to m into dp by dt. So mass into acceleration. So this is F external, which we have discussed in the previous slide. Right? So take a note of this and we'll go for the next topic in the upcoming session. Okay? Once you take this note. Okay, so I guess hope it's clear about the motion of center of mass, like velocity, acceleration, force, momentum, right? So based on this, questions can be asked in the EAPCET, right? So with this, I'll end this session of today's class. So we will continue with the next topic in the upcoming session, okay? And we will see some more questions in the upcoming classes. So thank you guys. Thank you for watching the NEET World YouTube channel. So please try to subscribe the channel, okay? Subscribe the channel and click the bell icon so that you can able to get the notification whenever we start the classes. Alright? Thank you.